Okay, so last class we started solving problems, application problems, modeling problems, and I know that this can be a really tricky topic. It can take a lot of practice and a lot of guidance before you really have a handle on how to solve these problems. So we're going to spend a whole nother class on this. The examples we worked so far could all be solved using one equation and one variable. Some of them we actually wrote two equations and two variables last class. And you can always do whichever one feels natural to you. If it feels natural to use two variables, go ahead and do it. And if it feels natural to just write one variable, go ahead and do that. So you want to do you always have the option. So we're just going to review more problems today. I think almost all of these we will set up in two variables, two equations. So here's a graph of a system of equations. I've got x plus 2y equals 2 and x minus 2y equals 6. So each of these equations, this equation and this equation, represent a line in the coordinate plane. And how you actually come up with that line we're going to talk about in a later class, but here they are. I just put them up for you. So each of those represents a line. And what do you think this intersection point tells us about that system of equations? Yeah. So what 4 represents which variable, x or y? X, and the -1 represents a y, right? Yeah, so 4, -1 tells you the x and the y coordinate for which these two equations are the same. So let's say I were to take each of these equations and solve them for y. So if I solve this equation for y, I'm going to end up with y equals 2 minus x over 2. And over here, I'm going to have y equals 6 minus x over -2. Right, so one of the things we did last class was solving for one variable in terms of the others. So what I saw, so what this intersection point says is that if I were to write the equation 2 minus x over 2 equals 6 minus x over -2, what would the solution be? X equals 4. Yeah, the solution would be x equals 4. What does the -1 represent? Yeah, it's the value on each side when you plug the 4 in, right? 2 minus 4 is -2. -2 over 2 is -1. When you plug the 4 into the right side, 6 minus 4 is 2 over -2 is -1. So when you check this guy and you plug 4 into each side of the equation, you get the -1. So we can solve a system of equations visually by graphing, but sometimes it's difficult to find a solution through graphing, especially if it's difficult to see. Like if the solution were 17/9, (-3/7), it's hard to tell that just by looking at a grid that only shows the integers. So luckily there are two algebraic methods we can use to solve these, substitution and addition. We did a little bit of substitution last class, so we're just going to officially review these two methods today. So here's my system of equations. 3x plus 2y equals 4 and 2x plus y equals 1. If I wanted to substitute, which equation would you pick to start with? Which equation would be the most efficient to start with? The bottom one. Why? The y has no coefficient, so it's easy to solve for the y. So you do not have to do this. Just if you're trying to be efficient, you say, okay, in the substitution method, you pick an equation and you solve for one variable in terms of the other. And the one that's easiest to do that for is the second one. So I would start with 2x plus y equals 1. Subtract 2x from both sides. So you get y equals 1 minus 2x. So I solved for the y in terms of the x. Then I go to my other equation. And instead of a y, I'm going to substitute the thing that y equals. That's why this method is called substitution. So instead of 2x plus y, I'm going to write 2x plus the thing that y equals. Substitute that thing because it's the same as y. 1 minus 2x equals 1. 4. Sorry, I didn't write the other equation. I'm going to write the other equation. 3x plus 2y equals 4. Substitute the y, 1 minus 2x. You're going to put parentheses around that thing because you're multiplying the 2 times that whole thing, because you multiply y by 2, so you have to multiply that whole thing that equals y by 2. Then we just distribute, combine like terms, solve this equation. So I have 3x plus 2 minus 4x equals 4. So negative x equals 2. So x equals negative 2. Am I done? Okay, so if I wanted to check, I would go back to my equations and say if I plug in a negative 2, is that equation true? I need something else to be able to check it. What do I need? The y, yeah. How do I figure out what the y equals? Plug x into the other equation, or either of the equations, really. But I already have one equation, all nice and solved for y. Y equals 1 minus 2x that I just rewriting it from over here. So now I'm just going to plug in the x that I now know. Substitute x equals negative 2 in, and we get y equals 5. Then, like Michelle said, I should check. I should always check. So if I put in a negative 2 for x and a 5 for y, I get 3 times negative 2 plus 2 times 5. Does that equal 4? Yeah. So I have negative 6 plus 10. Yeah, that equals 4. And the other one, 2 times negative 2 plus 5. Does that equal 1? Yeah. All right, so granted, I now know what the solutions are, but I just want to show you another method for how to solve this equation, this system of equations. So I have 3x plus 2y equals 4, and 2x plus y equals 1. So ultimately, this is called the addition method because I'm going to add the two equations together. Currently, adding the two equations together is not going to help me at all. What I would like to do is that when I add the two equations together, I want to have, say, a positive something y and a negative same something y, right? Like 7y and negative 7y, so that when I add them together, they add to 0 and they fall out. So I'm allowed to do anything I want as long as you do the same thing to both sides, right? Okay, so I'm going to go to the second equation, multiply both sides by negative 2. So I'm going to have negative 4x minus 2y equals negative 2. That equation is equivalent to the one that I just multiplied by negative 2. It's got the same solutions. So now I have a new equation, and I'm going to write it with my old equation. Oops. Now these two I add together. Add to, what's negative 4x plus 3x? Negative x. What's negative 2y plus 2y? 0y. So now I have no more y's. Negative 2 plus 4 is 2. So negative x equals 2, so x equals negative 2. So that's called the addition method. I'm not going to test you on the two different methods. If you have a favorite method, just do whichever one you want, right? So just showing you two different ways to solve this. So once you have x, pick either of your original equations and plug in for x to solve for y. So we end up with y equals 5. So let's just see a show of hands. Who's done this before? One method or the other? Okay, good. Good to know. Just not well. Well, you'll get good at it. Okay, so we did a problem like this last class, solving a dual investment problem. So we'll go through one together just to make sure that we all feel comfortable. So we have a scholarship fund that has $10,000 in it. We can invest in two different funds. One's low risk and one's higher risk. In general, a low risk fund gets a lower return on investment than a high risk fund. So for the low risk fund, we're going to expect 4% annual growth. And from the high risk fund, we're going to expect 8% annual growth. We want to make $550 a year, right? Because maybe that's the amount of scholarship money we give out. So if you put $10,000 in an investment, and then you can just every year give out a $550 scholarship without ever using the principal, without ever using the actual investment. You can just use the interest to award your $550 scholarship. So we have to invest this carefully to make sure we get $550 each year. And we want to put as little money as possible in the high-risk fund because high-risk funds are riskier. We might lose some of our investment. So how much do we invest in each fund? So we can solve this problem with one equation and one variable or with a linear system. Okay, so we're going to use two variables to solve this one today. Some students find writing a table like this really helpful in solving these types of story opportunities. Right, so just kind of organize all the information that was given to you into a chart. So I have a lower rate and a higher rate and a total, and then I have the amount I invested in each fund, the percent interest it's earning, and the amount of interest it earns. Okay. And the way you calculate amount of interest earned is the amount invested times the percent. So let's try to fill this stuff in with what they told us. So how much total money are we investing? 10,000. So I'm going to put that in my 10,000, in my amount invested in the total block. My percent interest, my lower rate is 4%, and my higher rate is 8%. I'm not going to, it doesn't make sense to, I mean, I guess I could fill that in later, but I don't need it. What is the total amount of interest I'm hoping to earn? 550. I can put this here. Total interest earned. And what did they ask me? How much should we invest in each fund? So let's have X be the amount we put at the lower rate and Y be the amount we put at the higher rate. And I should write that down. Officially, I should write let X equal amount in lower rate and Y equal amount in the higher rate. So just like last class, first search out the question. Search out the question and use it to define your variables. Then we fill in all this chart. Okay. So now the way we calculate the amount of interest you earn on an investment is you just multiply your investment times the percent, right? So just forget this question for a second. If I invest $100 at 8%, how much money am I going to make in a year? $8, right? You just do 0.08 times 100. That's your interest earned. So here I'm investing X dollars and I'm going to earn 4%. So the amount of interest earned is 0.04 times X. And then I'm going to invest Y dollars at 8%. So I have 0.08 times x times y. Thank you. Why do you multiply them? So that's how investments work. Like when investment says you're going to make a certain percentage, that means that you take the amount you invest, you figure out that percentage of it, and that's how much money you make. And the way you take percent of a number is multiplication. All right, so now I have to look at all this information that I've now organized nicely into a table and figure out what equals what. And I have two unknowns in this table, so I need two equations. What equals what? I need two equations here. Yeah, Tyler. 0.04x plus 0.08y equals 550. Good. So that is because if you earn this much interest from the lower rate fund and this much interest from the higher rate fund, when you combine them, you get a total interest of 550. Michelle, what are you going to say? X plus y equals 10,000. The amount you put in the lower rate plus the amount you invest in the higher rate has to give you a total of $10,000 invested. So now I have two equations, two unknowns. Do you have a preferred method on how to solve this? Should we do substitution or elimination? Substitution. I agree. I think substitution is probably the simpler way to go in this case because the coefficients in this equation are not nice. Right? So I'm going to solve for one of my variables over here because these are easy to solve for, right? Just move one variable over. So let's solve for, say, y. You could also solve for x. You just pick one of the variables, solve for it. So y is 10,000 minus x. So I come over to this other equation, and instead of a y, instead of putting a y there, I'm going to put the thing that it equals, 10,000 minus x equals 550. And then I try to solve this equation. So I'm going to distribute my 0.08. So 0.01 of 10,000 would move the decimal point 2 to the left, and then times 8, so I have 800 minus 0.08x equals 550. Combine like terms, so I have negative 0.04x. Move my 800 over. What's 550 minus 800? Negative 250. Yeah. 650, 750, 800. Yeah, 250. Nope. Count from 550 up to 800. So you go 550, 650, 750, 800. Right. If you've ever worked in like a place where you have to make change, do that counting back thing. Makes subtraction a lot easier. All right, divide by negative 0.04. And we get x equals, anybody have a calculator handy? 6,250. What are my units on that? Dollars. Yeah, because this is money that I'm investing. So, and then y, to find y, I go back up to this equation where I solve for y. And y is going to be 10,000, the total amount we're investing, minus the amount I put in, I can't remember if that was low or high risk, and I get 3750. So we should go back to where we defined this. Y was the amount in the higher risk fund. And X was the amount in the lower risk. All right, many applications where you're solving a system of equations or where you're finding a point of intersection of two graphs involve something called a break-even analysis. So if you want to launch a new product, it often requires a substantial investment. So you have to sell enough units so that the money that comes in will offset the big investment that you had to put forth to get started. So at the point where the money that you are making has completely paid off your investment, we call that the break-even point. So we're going to take a look at an example here. So technology is now promising to bring light, fast, and beautiful wheelchairs to millions of people with disabilities. A company is planning to manufacture these wheelchairs, and fixed cost is about $500,000 to get this company up and running, right? They have to purchase a building, they have to employ a bunch of people, they have to create the machinery that's going to put these things together, right? So we have a big upfront cost to get this business started. Plus, each wheelchair is going to cost $400 to produce. So there's a typo in your thing there. It should say 400. Each wheelchair is going to cost $400 to produce. Materials, electricity to run the factory, pay the employees, all costs $400. And then we're going to sell the wheelchairs for $600. Okay, so each wheelchair is going to make a profit, but all of that profit is going to have to go towards paying off this $500,000 before we start actually making any money. So we want to figure out how many wheelchairs have to be sold before the company breaks even. So I'm going to write an equation for revenue. The revenue for the company is going to be what? Money that comes in. 600x. So what does x have to represent then? The number of wheelchairs sold. So it's going to be 600x, and we're going to let x be the number of wheelchairs sold. All right, and what are their costs? 500,000. Just a one-time $500,000 investment, plus $400 for every wheelchair built. So how do I figure out the break-even point? Set them equal to each other. At what point will your revenues equal your costs? So we have 600x equals 500,000 plus 400x. When revenue equals cost, your profit is 0, right? Because profit is revenue minus costs. So I solve this thing by just getting 200x on the left equals 500,000, and x equals, don't tell me. So if I wanted to do this in my head, which is something you should all practice doing sometimes, I could divide it by 100 really easily. I just move the decimal point 2 to the left, so I would have 5,000. But if I'm dividing by 100 twice, what do I actually get? 2,500. 2,500 wheelchairs. So at the point where they have built and sold 2,500 wheelchairs, that is their break-even point. Now, after that, every wheelchair they sell is going to be pure profit. So let's take a brief look graphically of how to find the break-even point. Right, so I have an equation for revenue and I have an equation for cost, and I'm going to graph them. Okay, so my equation for revenue is 600x. So I'm going to graph the equation 600x. You can barely see it, but I'll fix the window after. And then my equation for cost was 500,000 minus 400x. Graph that, can't really see it, so I'm going to have to play with my window here. I don't have to look at anything negative because you can't build a negative number of wheelchairs. So x can't be negative. Actually, y could be negative though, because y represents money. No, it was 500,000. Oh yeah, plus. Thank you. Thanks. Yeah. So if we're only plugging in positive x's, we can only get positive y's. So revenue and cost, those things are always going to be positive. So I only have to look at positive x's, positive y's. And now I just have to play with this thing. I happen to know that the solution was 2,500 wheelchairs, so I need to really move this x scale. There we go. And then revenue and cost, each wheelchair costs $400 to produce. And if I'm going to sell thousands of them, those are big costs. So I need to look at a lot more y's here. You could also think to yourself, what's the y-intercept of this line? 500,000. So which means I have to be able to see that on the y-axis to be able to see my lines. There we go. Yes.
How would you say?
I'll do it on the calculator after this. Yeah. So what I need to know is where these two lines intersect. So I type intersect square bracket a comma b, and I get this point A, and I can't quite see the coordinates, so I'm just going to move my algebra view open more a little bit. And I get 2,500, which is an x coordinate, which means it represents x, the number of wheelchairs. And my y coordinate is 1.5 million. 1,500,000. What does that number represent? Its unit is in dollars, right? So at the point where your revenue and your costs are both $1.5 million is the break-even point. So when you've spent $1.5 million, at the point where you have spent $1.5 million to build these wheelchairs, that is the exact point when you have brought in $1.5 million. After that point, everything you bring in is profit. Number of wheelchairs. All right, so yeah, we should do the same procedure on a calculator. Okay, so in y1, I'm going to type in y equals 600x. y2, I put in 400x plus 500,000. And now I have to choose a window. So typically, if you have no idea, you start with the standard window, -10 to 10, -10 to 10. But in a real-world context, you can often guess better than that. So x is representing number of wheelchairs. So my smallest x I'm going to have be 0. Can't make fewer than that. And then I have to kind of guess, right, at what point the break-even point would fall. And you might guess wrong, right? So you might say, let's see what happens when I make 1,000 wheelchairs. And then for y, you say, well, I know y's are representing costs or revenues. And so if I did 600, so the smallest that thing can be is 0, right? Because it's representing an amount of money. And then what's 600 times 1,000? 600,000. So I got the 1,000 out of thin air, right? I said, let's see what happens if I do 1,000 wheelchairs. Well, my revenue would be $600,000. So this is just a total guess, like based on the context of the problem, but still a total guess. So I graph, and I can kind of see the lines, but I can see that they must intersect like somewhere way up here. So I need to look at more of the window. So maybe I'll go to 3,000. And for Y, I'll go to 1,000,000. Oh, almost. It's actually a little further up. Maybe I'll go to 2,000,000. Okay, I can just barely see where they cross. And then to get that point, you do second trace is the calculate menu here in yellow. And you choose option 5, intersect. And then you just press enter, enter, enter. And it'll find the intersection for you.